Hey Math 206, now that we've talked about the Pythagorean theorem, let's solve another problem. We'll calculate how tall is one of the Great Pyramids by just figuring out the length of the base and also what the slant height is. So let's start with a picture. So I'm going to draw myself a square pyramid. So here's my base, which has my base has a length of 771 feet, and I should make that back side a dashed line to show that it's in back. Put in the vertex here, and I'll draw in straight line segments connecting the apex to each one of the vertices in the base. Okay, so now the other piece of information I know is the slant height, which is the distance, basically the altitude of one of these triangles. So that is the altitude from the apex along the side of the pyramid, intersecting the base in a 90-degree angle. And that length there, that slant height, is 620 feet. And what I want to calculate is the height of the pyramid, which is basically the altitude dropping down a line segment from the apex down to the base. So imagine this being inside of the pyramid, intersecting the base in a 90-degree angle. I'll call that H here. And so what we'll do is we'll imagine this a 90 degree right triangle here inside of the pyramid. So let me kind of pull that triangle out, and we'll use the Pythagorean theorem to help us find the missing height here. Again, what we're looking for is the height of this triangle. I know the slant height here is 620 feet, and this distance, which from the center of the base out to the edge here, should be exactly half of the length of the base, of one of the sides of the base. So if this is 771 feet, then halfway is exactly this distance. So 771 divided by 2. So that's 385.5 feet. All right, now we can combine all this together using the Pythagorean theorem. The squares, add up the squares of the two legs, so h squared plus 385.5 squared should be equal to the hypotenuse squared. So now all we have to do is solve for h. I'll go ahead and do these calculations. 620 squared, that's 384 400, and 385.5 squared, what's that? This is 148,610.25. Okay, let's go ahead and subtract this amount from both sides. You get that h squared is 235,789.75. And then taking the square root of both sides, we get that h is approximately 485.58, so I'll round it to 6 feet. So the Great Pyramid is approximately 485.6 feet tall. All right, so now that we've done a few examples, let's go ahead and use our information, our ideas, to talk about some special right triangles which students need when they usually get into trigonometry. So our first special right triangle will be the 45, 45, 90 triangle. So these are isosceles right triangles. And here's how we can view them. You have your 90-degree angle and your two 45-degree angles. Now you know in an isosceles triangle, the two legs are the same size. So if this one's A, instead of calling this one B, I might as well call that A as well. And the third side, let me call it C. Now there's a special formula for figuring out what the hypotenuse is if you know what one of the what one of the legs is. If you have an isosceles right triangle, because we know this formula, a squared plus b squared, but my b here is a again. So a squared plus a squared equals c squared. So this is what, 2a squared equals c squared. So then taking the square root of both sides, we get that the square root of 2 times the square root of a squared, which is just a, is equal to c. So now if I know that, say, this is length 5 centimeters, then the length of the hypotenuse would be the square root of 2 times 5 centimeters. Okay? All right, there's another special right triangle, and that is your 30, 60, 90 right triangle. All right, let me begin by drawing in an equilateral triangle. And then let me drop down the altitude here. So in an equilateral triangle, you have three 60-degree angles, right? So this is a 60-degree angle here, and same thing here. This one, the 60-degree angle was bisected. So here I have a 30-degree angle. Okay. So also, if this length here, this base, which is half of the original triangle, but if that length, if I call that A, then the whole length of a side is twice A. And in my equilateral triangle, all the sides are the same. So this side, the hypotenuse, is also twice A. And now I can use the Pythagorean theorem to figure out what the third side would be. Let me call it x for a moment. The Pythagorean theorem says a squared plus x squared equals the hypotenuse squared, and the hypotenuse was 2a, remember? So 2a squared. Let me simplify this. A squared plus x squared equals 4a squared, because 2 squared is 4. Let me subtract the a squared from both sides, and I'll get x squared equals 4 minus 4a squared minus 1a squared is 3a squared. And then taking the square root of both sides, x would be equal to the square root of 3 times the square root of a squared. So square root of 3a. So this side is a, this side is 2a, and this third side, one of the legs, would be root 3a right here. So that's how the sides relate to each other when you have these special types of right triangles, which we could figure out the relationship between the sides without having to have any actual numbers to plug in first. All right, and the last thing with the Pythagorean theorem is that there's a converse here. So again, remember that the Pythagorean theorem, let me just call it PT for a minute, says that if A, B, and C are the sides, are the legs, and a hypotenuse of a right triangle. So here you're starting out saying that I have a right triangle and here's the three sides. Then, so if then a squared plus b squared equals c squared. And the converse of the Pythagorean theorem says that actually any triple of numbers that are related in this way have to have come from a right triangle to begin with. So the converse says if A, B, and C, let's make sure that they're positive numbers first. A, B, and C are positive numbers with a squared plus b squared equals c squared. Then A and B are the legs and C, the hypotenuse of a right triangle. So basically what that's telling you, excuse me, is that if you have a triangle and you know that the sides of the triangle are related in this way, then that triangle that you were dealing with has to be a right triangle. And in fact, you know which side is the hypotenuse. It's the longest one.